हाँ जी. Okay. So, good evening, all of you guys. A very good evening to all of you. I am live now, and जिन बच्चों ने भी क्लास ज्वाइन कर ली है, प्लीज़ आप एक बार मुझे मैसेज करके कंफर्मेशन दें दैट यू आर वाचिंग मी लाइव. ओके, एंड आफ्टर दैट वी विल स्टार्ट आवर टुडेज टॉपिक. आज काफ़ी सारा काम हमें करना है. सो माय प्लान इज लाइक, first we will go through the IPC, and after that we will start the doubts of your IPC, and after that we will start the doubt of your FM, and further we will go through the important topics of the fluid mechanics, right? So this is our plan for today. Let's see कितना हो पाता है. तो आज अपने पास काफ़ी सारा काम है. So please जल्दी से आप लाइव आ जाइए एंड लेट मी नो दैट यू आर लाइव. यस, गुड इवनिंग विष्णु, महीना, अनुष्का, देवर्ष, वेरी गुड इवनिंग टू ऑल ऑफ यू. ओके, सो अगेन थैंक यू सो मच फॉर बीइंग विद मी, एंड लेट्स स्टार्ट आवर टुडेज टॉपिक. ओके, सो in the previous session, we successfully discussed some topics like what is the Laplace. There are some important formulas: final value theorem, initial value theorem, and the basic of the inverse Laplace, and the partial fraction formulas, and what are the forcing functions or the input functions, in which we discuss the step input, the unit pulse input, impulse input, ramp input, and sinusoidal input, right? Their function in t terms and their function in the s terms. After that, a very important thing, that is the deviation variable, and what is that and all that we have discussed. Okay, after that we discuss the first order system, right? And the first order system transfer function and the step response of the you can say first order system. Okay, and after that we have discussed the new terms for us, that is Kp and tau p, steady state gain, and the tau p, time constant, right? After that we have discussed some examples of the first order system like mercury thermometer, and in the out of 3 to 4 examples, the main important thing, or you can say the main you can say the important for the gate perspective is the value of Kp and tau p, right? If we know the value of the Kp and tau p for particular example, then by comparing the transfer function or the first order system, we can manage the transfer function of that particular example. Like in the mercury, my Kp value is 1 and tau p value is my mc upon ha, and in that session we so that tau p is my product of capacitance into the resistance. After that, the liquid level tank, where when we talk about the level tank, it means my main output is to maintain the height of the tank, right? Height of the tank means the liquid height in the tank. Okay, so after that, 2 outlet system, and after that mixing tank and the energy storage, right? So these are the 5 examples of the first order system in which you have to remember the Kp and tau p value. Okay, done. After that we have discussed the second order system, and this is the basic equation. So with the help of the second order differential equation, we can write the, and you can see we can model the second order system. So here in the second order system, there are you can say the 2 terms are new for us, like tau p. Here tau p is my natural time constant, and the zeta, that is the damping ratio and the damping coefficient. Based upon the value of the zeta, we define the system overdamped, underdamped, and the critically damped. These are the 3 important damped system we have. Okay. Okay. So like you should remember what are the roots for the particular value of the zeta, and that system is basically what is the name of that system, right? Like for example, for zeta is equal to greater than 1, roots are real and unequal, and the system is called overdamped. Likewise, we should remember all these things. हाँ जी, Also, important point, you should remember about the relation between the zeta and the oscillation, that at which value my oscillation is, what kind of oscillation I can face, right? Is it clear to you? So this is the very important line. In this case, the magnitude of the oscillation will same. Yeah, the zeta kills the oscillation, right? So ये आप दिमाग में रखेंगे up to the 1. After that, overdamped system. Underdamped system in which zeta value is less than 1. In the underdamped system, there are two terms which are very important: overshoot and the decay ratio, right? So you can say terminologies is very simple, and you can see the question based on that. Simply formula putting question, right? If you have the zeta value, you can calculate the overshoot, and further with the help of the overshoot, which is the ratio of A by B, these constant A by B will help you to calculate the value of MVR and the UVR. Okay, and ठीक okay. After that, multi-capacity of the second order system means one tank stands for first order, so two tanks stands for the second order. So in which non-interacting and interacting, what are the difference in the interacting and non-interacting, and what are the difference in actually the, you can say the, in the transfer function. Only the difference is of the interaction factor. So in the interacting system, you will see A1 R2 interaction factor, and you will not see A1 R2 in the non-interacting system. After that, we have discussed the dead time. So simply dead time transfer function you should know, e raised to power minus tau ds. Okay. After that, we have discussed the closed loop control strategy. In this strategy, we discuss the regulatory mode and servo mode. You should know about what is the regulatory and what is the servo mode, because these terminals are very, very important. For overall process, set point and the load is, you can say, input for me, and y is my output for me. For regulatory mode, d is changing, so we have to calculate y by d. In servo mode, r is changing, so we should calculate y by r. That's it. For a closed loop, how to calculate the transfer function, this is the shortcut. We already discussed it. Okay. How to calculate the steady state gain, I already discussed about it. Okay. For unit step input, if you calculate the y infinity, that is a steady state gain. Okay. Offset, very, very important. R minus y infinity is the formula. For servo mode, it is this. For regulatory modes, it is minus y infinity. We have discussed three controller, P controller. This is the base equation you can see in the box, and the negative point is offset. That is eliminated by the integral action, but the negative point for integral action is it increases the dynamics, which makes the system sluggish. That is eliminated by the derivative action, है ना? And that is the derivative action वाला term, kc tau d de over dt, right? And this is the, you can say, the last is your transfer function of the PID controller. Okay. In the Routh test stability, I already told you how to make the rows, right? And विष्णु आप पूछ रहे थे सर nth रो क्या है? nth simply जो last रो होगी वही तो nth होगी. nth का मतलब क्या है? Like in this equation, my higher order, maximum order क्या है? 4, right? So कितनी rows बनेगी? 5 बनेगी. तो n की वैल्यू क्या है? वहाँ पे 5 है, right? So the last row will be the nth row. Okay. Already discussed the feed forward control strategy, in which how to calculate the transfer function of particular GC and GSP. I already told you. Okay, the feed forward control strategy is to for the perfect rejection of the disturbance. Okay, and their advantages we already discussed. How to calculate poles and zeros already told you guys, right? Also discuss the inverse response, and remember the main condition for the inverse response, that there must be a positive zeros. For that, if the for the positive zeros, and when we calculate the positive zeros, then we basically get this equation, k1 over k2 must be greater than tau 1. Okay, so these are the whole discussion which we previously discussed, guys. So in I think in 10 minutes I revise all the things. I hope that the memory is you can say कि अभी फिर से fresh हो गई होगी, right? Now we will discuss the control valve, right? So in the control valve, or you can say that is your final control element. In the closed loop control strategy, we have discussed a diagram. In that diagram, controller will take action. Controller will say anything to a wall, which is basically a cooling water wala wall. अगर आपको ध्यान हो, that is called a final control element, right? So final control element is nothing but it is the control wall itself. Okay, is it clear to you? Okay, guys. So there are two types of the control wall. That is the air to close and air to open. Okay, so very simple terminologies we are using here. Air to close means if air pressure signal is coming into the wall, then wall positioning will be going towards the close. Okay, and in this type of case, air to open means air signal comes into the wall, then it is going towards the opening position, right? So this is the meaning of air to close and air to open. Very important slide. Air to close means if air is coming in the control wall in terms of pressure signal, then my control wall basically going to be open, right? खुलेगा वो. So before opening, what is the position? That is the close position. So if that wall is basically failed, there is any hardware malfunctioning in the wall, it means your wall is not working. If your wall is not working, then what is the initial position of that wall? That is the close. That's why it is called fail to close. That is called fail to close, right? Similarly, air to close. So if air is coming, if pressure signal is coming, then wall is going towards the close position, right? So it means if wall is, you can say, gets failed, then it is in the position of open, right? Air to close or fail to open is called direct acting. Okay, it is called direct acting. ध्यान रखना ये, इसी पे बेस आपके काफी डाउट आए मेरे पास में. Direct acting. And air to open is the reverse acting. It is my reverse acting, guys. Okay, so समझ में आ गया? Please let me know that this is clear to you or not. Remember always, air to open is your reverse acting, air to close is your direct acting. Okay. Okay, so now guys, there are three characteristics of the wall. That is the linear, equal percentage and quick opening. Quick opening is also called square root wall. So this is the, you can say your, the relations between the input and output. Linear means that the, with respect to y and x, the relation is linear, means the slope will be the constant value, right? And in the, for the 2, it is my equal percentage and this is my quick opening. Just remember this, है ना? और ये बैकग्राउंड म्यूजिक के लिए मुझे माफ करना भाई, क्योंकि जो है इसमें हम कुछ कर नहीं पाएंगे. Yeah. So 1 is stands for the linear. The slope is my df over dx. Okay. And this wall is my linear, constant. ये मतलब input और output के साथ ही constant. See, sensitive is my df over dx. So for the linear, it should be constant. It is for the linear, it is my constant. Means you can say by changing input. अगर आप input को change करते हैं, the output will be the constant value. Output you are basically getting, that is constant. So just remember this diagram. That's it, nothing else. This is a very important slide, guys. Just see this slide. This is important. Okay. Means with the help of this good evening here, with the help of this slide you can solve any question of your related to the wall. And I think 1 or 2 questions I'm getting जो आपके कंट्रोल वॉल से ही है. ठीक है, अब समझो. लेट्स डिस्कस अबाउट दिस. Direct acting. These two lines are for wall. What is the meaning of direct acting in case of the wall? डायरेक्ट एक्टिंग ध्यान है आपको क्या है? मीन्स इट इज माई एयर टू क्लोज और एयर टू ओपन, प्लीज बताइए. It is my air to close or air to open. Means if signal is coming, then my wall is going to towards the closed position or open position. बोलो डायरेक्ट एक्टिंग में. जल्दी बोलो. Yes, it is air to close. So it means if pressure signal is increasing, wall is going to towards the closed position. It means if wall is closed, wall is going to towards the closed position. It means the flow area for the liquid is basically decreasing. So can we say that flow is going to decrease? Okay. So if signal is increasing, my flow will decrease. It is my direct acting. For reverse acting, if my signal is increasing, flow is also increasing. Flow is also increasing. That's it. In the controller case, if my controller is direct acting, it means if the process variable value will increase, my output also value will increase. My output value also increase. Okay, and reverse acting, if my process value will increase, my output value will decrease. Right? If let's suppose if my control is direct acting, process variable, let's suppose temperature is increasing. What is the output of the controller? Output of the controller is the signal which is basically going into the controller. So if my temperature is increasing, output will increase. So output will increase means that the signal which is going into the control wall, that is basically increasing signal. This wala signal, this is the signal. Okay, yeah. So in the reverse acting क्या होगा? That if my temperature is increasing, then controller will decrease the output. ठीक है? Okay. These are the thumb rules, guys. Just you have to remember this to maintain the liquid level. Use P controller. For gas pressure control, P control. Vapor pressure, PI. Flow control, PI. Temperature, PID. Composition, PID. Okay. ठीक है. So based upon these things, I will solve your doubt. Okay. जो मेरे पास doubt आया है उसको हम solve करेंगे, फिर बेहतर तरीके से आपको clear हो जाएगा. Now, let's discuss now the next chapter, that is the frequency response. In the frequency response, my input is basically sinusoidal, right? Which is a wave function. As you know that since 11th class, you know that sine function is a wave function. So output is also my wave function, right? Is it clear to you? The purpose of this chapter is to check the stability of the system and finding the Kc value. Kc is my gain for the controller, right? So that what should I keep the value of Kc for the stability? That is my Kc. So with the help of this chapter, we basically calculate the value of Kc for the stability of the system. Also, we can check for the instability and also with the at the verge of the stability. The method is very, very simple. In this method, basically we put S is equal to I omega. S is equal to I omega, and we make this form A plus iota B and a complex number form. Right, and with the help of A plus iota B, we will calculate the amplitude ratio, right, which is my magnitude of the output divided by magnitude of the input. Magnitude of the output divided by magnitude of the input. This is called by the amplitude ratio. Okay, remember this. This is the first order system. This is the AR of the first order. Kp divided by under root 1 plus tau p square omega square. Very, very, very important formula. Okay. Now, with the help of A plus iota B also, we calculate the phase angle. Phase angle is my tan inverse minus tau p omega. Right? This is for the first order system. For the P controller, it is my Kc. So guys, if you have a constant number, then the amplitude ratio itself the constant number. है ना? मैं यहाँ पे लिख रखा है. AR for any constant term is constant itself. And for any constant, your phi will be 0. Remember this. For PI controller, AR is my KC under root 1 plus 1 divided by tau I square omega square. If you remember this, well and good. Otherwise, just put S is equal to iota omega, convert A plus iota B, and calculate AR and the phi. No worry. If we will talk about the phi for the PI, then it is phi is equal to tan inverse minus 1 over tau I omega. And these are the phi limits, which is a very, you can say, simple thing, trigonometric and nothing else. Very, very important for the transportation lag. For the transportation lag, remember guys, very, very important that amplitude ratio is 1. Remember this, amplitude ratio is 1 for the transportation lag. Right, and phi is my minus tau d omega, and remember this minus tau d omega, that value is basically radian. We have the two terms, one is a radian and one is a degree. Radian is simply a number and degree is the 60 degree, 30 degree, like that. So you should be very clear about this, that in the particular equation that unit consistency must be there. In that case only you can solve any question. Right, you cannot add 5 aloo plus 5 tomato, right? Okay, aloo must be added into the aloo, right? So the whole equation must be in the radian or the whole equation must be in the degree. Remember this. If there is any you can say agar consistency nahi hai, if consistency is not there, then you can convert radian into degree by this and degree into radian by this, and this is your you can say the very simple things, and I hope that you guys are aware about it. So for the first order system, what is AR and phi, for what is AR and phi for PI, for PID, anything I can calculate it. But what if two systems are connected to each other in the series combination? Then this slide is a very, very important guys. The amplitude ratio, overall amplitude ratio is the multiplication of the individual AR, and the phase angle is the addition of the individual phi. Right? This is how we can calculate the overall terms in terms of AR and the phi. Okay. Bode diagram. So I think there is no need to discuss the Bode diagram guys. Bode diagram is nothing but it is the log plot for the AR versus omega tau p. Just remember this omega c is equal to 1 by tau p, and this omega c is called my corner frequency. This omega c is my corner frequency, right? What is this corner frequency? The frequency at which my amplitude ratio is a start to changing. Okay, if your transfer function is 1 divide by in the denominator, if you are seeing the tau ps, then your the Bode plot will going to decrease with the -1 slope, right? Is it clear to you? Just see here, what if it is 1, then put here 1. If it is 10, then put 10 here. It basically shows the kp value. So in this particular case, what is the value of kp? 1. So just put here 1. Now just see what is the corner frequency. Sir, how I calculate my corner frequency? Corner frequency is 1 divided by tau, nothing else. What is the tau? By comparison, I can know. I know what is the tau. Tau is this. Remember guys, this must be 1. In this case only you can compare this with the kp and tau p. है ना? ये ध्यान रखना, यहाँ पे गलती हो सकती है. Just see this. It should be in the form of +1. Okay. So these are the basics, and आप सबको पता है, but क्या करूँ, मुझे लगता है कि मैं सब कुछ ही बता दूँ आपको, है ना? तो 1% ही चांस ना बचे किसी गलती का, इसलिए मैं छोटी से छोटी चीज भी बताने की कोशिश कर रहा हूँ. I know there is no requirement, but because the time is also very, very less, but still मैं चाहता हूँ कि कोई भी एक सिंगल मिस्टेक आपसे ना हो, इसलिए I'm repeating all these fundamental things also. Yeah. So here by comparison, what is tau p? 5, and with the help of 5 I can calculate corner frequency. Corner frequency is 1 by tau p, 1 by 5, that is 0.2. It means after 0.2 it is going upward or it is going downward. How I decide that it is going upward or downward? If this term is in denominator, then it is going in the downward direction, and if it is in the numerator, then it is going with in the upward direction with the slope +1. That's it. Okay. Okay, if this is the kind of transfer function kp over s, then this is the basically going with the -1 slope in from AR itself. यहीं से ही वो नीचे की तरफ जाएगा, right? Is it clear to you? And if it is similarly, वही है यार, यहाँ पे अगर नीचे है, इफ यू कैन सी s इन द डिनोमिनेटर देन इट इज गोइंग डाउनवर्ड. अप है तो अप जाने दो, नीचे है तो नीचे आने दो. वेरी सिंपल टू रिमेंबर. हियर इट इज इन द न्यूमरेटर, है ना, डिवाइड बाय 1 कर सकते हैं ना, kps divided by 1, and I can say it is kps in the numerator, then it is in the upward, then go with the upward with the plus 1, right? So just do not confuse in this. If I can plot the body plot with the in the system in series also, just क्या करना है, individual आप plot कीजिए, individual plot कीजिए आप इसके अंदर, and just add the slopes. That's it guys, add the slopes, nothing else. So first, अगर कोई मैंने टिपिकल एग्जांपल ले रखा, अच्छा टिपिकल एग्जांपल तो ले रखा था, बट यहाँ पे इसमें मैंने नहीं लिया. ओके, नो वरी. सी जस्ट whatever is your function, just first calculate the corner frequency, that how much corner frequencies are possible. Like in this, there is 2 tau p, 1 tau p is this, there are 2 tau p. It means the 2 corner frequencies are there. So just mark these corner frequency like 0.33, 0.5. And separately first plot the body, and after that just add the corresponding slopes. Like in between 0.33 and 0.5, this slope is 0, this is -1, so this is my overall -1. Okay, above 0.5 I can here see the 2 lines of the -1 slope, है ना. Just forget about this वाला part, है ना. अब हम इस part की बात कर रहे हैं, between this, इसकी बात कर रहे हैं. So it is -1, so it is -2. Guys, please give a thumbs up अगर clear है तो, and after that I will move forward. जल्दी बोलो. और हाँ, अगर आपको कोई डाउट भी आता है ना बीच में, यू कैन आस्क, देयर इज नो प्रॉब्लम, आप पूछ सकते हैं. इफ यू हैव यू कैन से एनी प्रॉब्लम, पर्टिकुलर प्रॉब्लम, अगर यह कुछ समझने में है तो आप मुझे तुरंत बता सकते हैं, अभी हम बात कर लेंगे उसके ऊपर. देयर इज नो इशू. ऐसा नहीं है कि ठीक है ट्रेन चल रही है तो पूछे ना. इस पर्टिकुलर स्लाइड में जो हम स्लाइड डिस्कस कर रहे हैं, है ना, कोई और कहीं से कुछ उठा के मत पूछना. यहाँ पे जो स्लाइड में आपको कॉन्सेप्चुअली अगर कोई प्रॉब्लम आती है तो आप मुझसे पूछें, ठीक है. बाकी क्वेश्चंस तो मैं आपके डिस्कस करूंगा ही बाय एंड ऑफ दिस लेक्चर. This is also very important, you can say guys, statement. In the Bode stability criterion, a control system is unstable. Unstable होगा कब? If open loop frequency response, means we are discussing the open loop here. If the open loop amplitude ratio is greater than 1, right? If amplitude ratio is greater than 1, right? So it means, see, this is my block diagram. But this block diagram, see, please आप ध्यान से सुने इस बात को, please ध्यान से सुने. This is my block diagram, and you can see that this block diagram is my closed loop. So just don't worry. Just imagine that this is the open loop. And in the open loop, what we basically, how we calculate the transfer function for the open loop, just multiply all the transfer function. That's it. Like Kc, Gf, Gp, Gm. That's it. So this is my open loop transfer function. Now just calculate just put the phi, means the overall phase lag of the open loop transfer function -180. Okay, first you calculate the transfer function, open loop transfer function. How calculate? Just multiply the transfer functions, and I know the formula for the phi for each and every term, whether it is of that time, whether it is of first order, कुछ भी हो, I know this. Now put that, and how phi क्या होता है? Just we have to add the phi. If the system is in the series, then phi must be added. So just add the phi for individual transfer function and equate that phi to the -180 degree. Add this value, whatever you find the omega, that is called crossover frequency. That is called crossover frequency, right? First we write the open loop transfer function. After that we calculate overall phi. How? Just add the individual phi, equate that overall phi to the -180 degree, and with the help of this calculation I can calculate my omega frequency. And that frequency is called crossover frequency. Okay, done. Now we have the open loop transfer function. Now calculate the amplitude ratio of that open loop transfer function. Amplitude ratios are the multiplication of the individual transfer function. So first calculate the individual amplitude ratio for each and every transfer function and multiply. Okay. Now whether where you find the term omega, put the omega c naught value there, right, and calculate the AR value. Calculate the AR value, right? So the whatever you get the AR value, it may be possible that you will get this greater than 1. It means this system is unstable. If this is the value, means it is equal to 1, then it's the verge of the instability. And if the amplitude ratio you are getting less than 1, it means that this system is stable. This system is stable. Please guys, let me know that this is clear to you or not. Please जल्दी बोलो, क्या आपको ये बात क्लियर हुई? Everybody please, क्या आपको ये बात क्लियर हुई? What I'm trying to say, how I explain this, how I calculate AR, बोलिए. जितने भी लाइव देख रहे हैं सबके सब बताएंगे. हाँ जी बोलिए. I'm waiting. Okay, yeah, done. ठीक है, हाँ जी. Now let's talk about the Kc value. Okay, what I told you that body stability criterion, frequency response से related topic है ना. This is used to basically check the stability, right? And based upon these equations we basically can talk about the stability, right? हाँ जी. So simply this slide is important. See, phi naught, put phi naught is equal to minus 180. Calculate the crossover frequency and now find out the overall AR at that crossover frequency. It is greater than 1, unstable, equal to 1, at the verge of instability, less than 1, stable. That's it. Right? Now very important. Let's suppose you are getting this at omega c naught. You are getting overall amplitude ratio is equal to 1. Okay. So the value of the Kc, for which overall amplitude ratio at the crossover frequency is 1, that is called your ultimate gain. Then Kc is not Kc, now Kc is Ku, which is your ultimate gain. So if somebody is asking how to calculate the ultimate gain, मैं बोलूंगा कि now if anybody is asking about the ultimate gain, it means I should put AR, overall AR at crossover frequency is equal to 1. This is the predefined condition now, because ultimate gain is only calculated for the AR1. So how to calculate the value of Kc, or you can say how to calculate the value of Ku. Actually Ku is ultimate gain. Just put overall AR at crossover frequency is equal to 1 and find out the value of K. That value will be your Ku, nothing else. Time period of oscillation is nothing, it is my time period of oscillation. क्या होता है? It is my 2 pi by omega. Now ultimate time period of oscillation क्या होता है? It is nothing, it is 2 pi divided by omega c, right? That is the crossover frequency. Okay, so if you calculate the time period of the oscillation at crossover frequency, that is your ultimate time period of oscillation, that is Pu, right? So these are the two terms which is important for us, Ku and Pu, because these are the parameters which is useful in the Ziegler-Nicholas setting. Okay, if you any doubt, please drop a message. Next, सो आई हाँ जी, ये जिगलर निकोलस स्टैटिक. सो this is the tuning, that what we should keep the value of p, what should we keep the value of pi, what should we keep the value of pid. This is all about the tuning, है ना. स्टेबल सिस्टम के लिए हम पैरामीटर्स की वैल्यूज क्या रखें. ओके, लाइक वी हैव थ्री पैरामीटर्स kc, tau I and tau d. For p it is only kc, for pi it is kc and tau I, and for the pid it is kc, tau I and tau d. So for the stable system, these are the predefined values. You have to remember this. ठीक है. नहीं, क्रॉसओवर ही है बेटा, क्रॉसओवर ही है, क्रॉसओवर पे ही होगा, क्रॉसओवर पे ही है ना ये वाला ना. दिस इज ऑन द क्रॉसओवर. ओके, राइट. कॉर्नर को भूल जाओ. कॉर्नर इज ओनली यूज टू कैलकुलेट द बॉडी प्लॉट. क्या, हाँ जी. सो this is how you can keep the value of the parameters for the stable system. Done. Now there are two terms, gain margin and the phase margin. So with the help of this diagram I will tell you what is the gain margin and the phase margin. So I think this is very clear to you that for the stable system, AR, amplitude ratio, must be less than 1. Great, right? And it is also in the phi system, in the phi terms, it should be less than minus 180. Okay, now I will calculate phase margin. So how to calculate the phase margin? देखो, if you are interested to calculate phase margin, then AR से चलो. Put AR equal to 1. Put AR equal to 1. At AR equal to 1, calculate the value of the phi. Right? Array, you have a transfer function and you are able to calculate the transfer function. You are able to calculate the overall AR for that particular transfer function, and you are able to calculate phi for that particular transfer function. You have two things in your mind, and they should be clear in your mind. Put AR equal to 1, and at AR equal to 1, calculate the value of the phi. Right? Calculate the value of the phi. Okay? And actually अगर मैं आपसे एकदम ही क्लियर मैं आपको बताऊं, तो क्या होगा आपका. देखो, put AR equal to 1. At this AR equal to 1, what you will get? You will get the omega. You will get the omega. This is any random frequency. This is any random frequency, right? At this frequency, calculate the phi. Calculate the phi. And put that phi in this formula. Put this phi in this formula, right? This is the phi plus 180. Put this phi in the formula. You are able to calculate the value of phase margin. That's it. Put AR equal to 1. Calculate the frequency. At this frequency, find out the phi. And this phi put here. That will be your phase margin. Okay? Is it clear to you? Hanji. Okay. This is the last topic. Okay. Now, what about the gain margin? Put phi is equal to minus 180. Put phi is equal to minus 180. And minus 180 page, if I put phi is equal to minus 180, whatever the frequency I am getting, that is my crossover frequency. That is my crossover frequency. And that frequency is basically, at this frequency, I will calculate the amplitude ratio, A. Right? And divide one, reciprocal of this is gain margin. Reciprocal of this is my gain margin. This is the formula. ठीक है? तो just एक बार रिवाइज कर लेना है इसको. ठीक है? So this is the thing guys. ये आपका पूरा एक PDC था. मतलब मैंने जो है आपको I think सारा PDC जितना मैं करवा सकता था. मतलब मैंने I hope कि मैंने सारे जो हैं इन सारे इंपॉर्टेंट टॉपिक्स तो मैंने कवर किए हैं. और I think मैंने लगभग सब कुछ ले लिया है इसके अंदर, है ना। कोई हो सकता है कोई छोटी मोटी चीजें मैंने छोड़ी हूं, अदरवाइज जहां तक मुझे लग रहा है मैंने सारी की सारी जो है यहाँ पे सारी की सारी टॉपिक्स को कवर कर दिया है, राइट। नाउ देर आर सम क्वेश्चंस जो आपके हैं यहाँ पे, वो अब मैं डिस्कस करने वाला हूं। ओके, आर यू गाइज रेडी? प्लीज बोलो, आर यू गाइज रेडी? कैन वी डिस्कस? जो आपके चैट के थ्रू मेरे पास आए हैं क्वेश्चंस, नाउ आई विल डिस्कस दोज क्वेश्चंस। प्लीज प्लीज बताइए मुझे क्या कर सकते हैं, बोलिएगा। बोलिए। Okay, chaliye. So guys, see, this question is actually you can say, we can say that this question is important, है ना। जिसने भी भेजा मुझे आइडिया नहीं है, ध्यान नहीं है मुझे किसने मुझे भेजा। दिस इज एक्चुअली अ काइंड ऑफ अ पजल, एक पजल की तरह है। वी हैव एक्चुअली टू मेथड्स टू कैलकुलेट द क्वेश्चंस। इफ देयर इज अ स्टैंडर्ड लूप, we have a shortcut, and if the loop is non-standard, then with the help of we assigning some constant, calculate the values, and by separating that constants, eliminating those constant, we are basically we will calculate the transfer function. In this particular type of problem, the problem is you are basically stuck in a loop, है ना। ना चाहते हुए भी आप यहां पे एक एक्स्ट्रा कांस्टेंट असाइन कर देते हैं, एंड यू आर बेसिकली स्टक इन अ लूप वेयर यू अल्टीमेटली यू कैन नॉट गेट योर रिजल्ट। दिस इज अ प्रॉब्लम। इफ यू कैन नॉट रिलेट विद माई वर्ड्स, देन एक काम करना, इसको अपने कांस्टेंट रखने वाले मेथड से एक बार कैलकुलेट करने की कोशिश करना, तब समझ में आएगा कि जब मैं सी रखने जा रहा हूं तो वापस से ए आ रहा है, मैं जब ए रख रहा हूं तो ए फिर से सी की टर्म्स में, लाइक यू सपोज यू आर असाइनिंग ए बी सी, है ना, एंड द रिलेशन बिटवीन सी एंड ए इज देयर। व्हेन यू पुटिंग सी यू आर गेटिंग ए, एंड अगेन यू आर गोइंग टू एलिमिनेट ए, यू आर अगेन सी द सी इन द टर्म्स। एक बार इस टाइप का क्वेश्चन शायद गेट में भी आया है। नाउ सी, मैं बहुत ही क्लियर वे से बता रहा हूं, दिस इज ऑल अबाउट मैथमेटिक्स गाइस। वहां पे आपको जो है, अगर आपके दिमाग में आपका दिमाग चल गया तो आप इस तरह की प्रॉब्लम कर दोगे, अदरवाइज तो स्टक हो सकते हो। बट अगर आपको ऐसा लगता है कि स्टक हो सकते हो, देन माई एडवाइस फॉर यू इज जस्ट असाइन अ वन वेरिएबल, दैट्स इट, नथिंग एल्स। एक ही कांस्टेंट, है ना, वेरिएबल बोलो कांस्टेंट बोलो, एक ही कांस्टेंट आप असाइन करें, दैट्स इट। डू नॉट consider so much constant. If you are consider so much constant, then there will be a problem for us. Now how I assign a constant and how I basically try to solve this question, just see, do one thing, see, this is the any signal is going into this stream, and that is 2, that is going into this by addition of this is any signal going into this, and by this comparator, this is basically what it is, my y, right, it is going there, and here also going y, it is also my y. So what is that output is my input into transfer function. So what is this signal guys? This signal is my 25y. Unnecessary, do not consider the constant like a, this is b, this is c. If you are assigning these constant, you will stuck, ठीक है। मैंने भी पहले ऐसे ही कोशिश की, बट मुझे आंसर नहीं मिला। फिर मैंने क्या ट्राई किया, आई जस्ट असाइन अ वन कांस्टेंट। I assign the C here, that from this transfer function C is coming, so C is going there and C is also going there. That's it, nothing else. बस मैंने ये किया. Okay, now I can make a equation now. ठीक है? So what is y? What is y? Y is equal to my C divided by S. Yeah? Yes? Is it clear? What is the input of this transfer function? C. So it is my C and input is 1 by S. So it is my C is equal to y is equal to C by S. So it is my C is equal to y into S. So this is, let's suppose, equation number 1. Okay. Now see, this is my C, this is my X. So what is this signal? What is this signal? X plus, because this is the plus plus, it is by 2 into C, right? What is the signal? 2 into input 2C. So X plus 2C is going here and 25Y is going here. So what is this signal, guys? This signal is, let's suppose I'm writing here, this signal is X plus 2C and minus 25Y. Right? This signal is going here. Great? Yes? Okay. So it is my X plus 2C minus 25Y. Right? This is the signal. What is the C? Let's suppose this equation number 2. What is the C, guys? C is equal to input. Input is this. Input is this. It is my X plus 2C minus 25Y and into transfer function. Transfer function is 1 by S. So it is my. I hope this is clear. Please let me know that this is clear to you or not. Please let me know that this is clear to you or not. So I think one equation, one unknown is there. I think I can solve this equation. I can solve this part, right? Please tell me equation 1, 2 and 3 is clear to you or not. Just see the equation number 3. It is my CS is equal to X plus 2C minus 25Y. Now we have to eliminate only C. So how we can eliminate the C? We have the C in terms of Y. So put here, it is my YS square is equal to X plus 2. Again put the C. C is my YS minus 25Y. I think I successfully we eliminate the we successfully eliminate the constant, right? What we have to calculate? We have to calculate offset. Okay, so for offset, first we need transfer function. Transfer function. What is the output? Y. What is the input? X. So we have to calculate y by x. Okay, so I think just आप एक काम कीजिए, y को एक तरफ कर लीजिए. So it is my y is common, s square, this term minus 2s and this term plus 25 is equal to x. So my y by x is equal to 1 divided by s square minus 2s plus 25. This is my transfer function. So this question may be in terms of the transfer function or maybe in any terms, है ना, किसी भी terms में ये question आपको मिल सकता था. So this is how you can calculate the value of all the transfer function of these type of questions, है ना. If you can try at the home and by assigning the ABC constant, and you will not land up with any result. Now the question is very simple. We have to calculate the offset. Okay, is it clear to you? ठीक है. Offset, what is the formula for the offset? Offset is equal to magnitude minus y infinity, right? Okay, so here unit step input is given to us. So magnitude for the unit is 1 minus y infinity. Just calculate the value of y infinity here. My y by s is equal to 1 divided by s square minus 2s plus 25. What is the s? S is my unit step input, right? Y infinity. For y infinity, just multiply s and put s tends to 0. S gets cancelled. This is 0. This is 0. So my y infinity is 25. Put here. It is my 1 by 25. 1 by 25. So it is my 1 divided by 25. So what we will get offset? 24 divided by 25. So I think this is my correct option. Please let me know if you have any problem. Let me know if you have any problem, guys. Clear or not? ओके ठीक है, डन. नाउ एक ये क्वेश्चन था हमारे पास में. आई थिंक देयर इज नो नीड टू डिस्कस दिस क्वेश्चन. मैंने कल भी आपको बताया था इस क्वेश्चन को. इस क्वेश्चन को कैसे कर सकते हैं? वेरी सिंपल वे. जस्ट कैलकुलेट. सी ये बहुत बड़ी कैलकुलेशन है, बहुत टाइम खा जाएगा अपना, तो देयर इज नो नीड टू डिस्कस दिस. आप सुन लो एक बार बस. आर वी एबल टू कैलकुलेट द ट्रांसफर फंक्शन ऑफ दिस ब्रांच? यस सर. लेट्स सपोज इट इज एक्स. Right now, this is the problem of the stability. ठीक है, we can calculate this question with the help of Routh array. Yes, Routh table से हम Routh array से हम कर सकते हैं. Yeah, we can do this. For Routh array, what is the first requirement? Characteristic equation. What is the characteristic equation? The transfer function denominator equation. Transfer function is for the closed loop. It is my it is whatever it is, numerator divided by 1 plus OLTF. Right? This is closed loop. I will write the transfer function between y and x divided by 1 plus OLTF. So transfer function denominator equation is equal to 0. This is my characteristic equation. Right? So 1 plus OLTF means the transfer function this multiply by whatever we calculate here and multiply by this. I put here equal to 0 and I calculate a equation. Equation बना ली. उसके बाद हम क्या करेंगे? We make the Routh array. We make the Routh array. By making the Routh array, it is asking about the stability system. What is the value of the Kc for the stable system? So the first column, for first column of the Routh array must be positive. So, जहां पे भी आपको k कहां गया अपना, या KCM दिखेगा जिस भी रो में, जहां पे कांस्टेंट है वो तो कोई दिक्कत वाली बात नहीं है. लेट्स सपोज इट इज द फर्स्ट कॉलम विल बी लाइक दिस 4 5 एंड दिस इज एनी फंक्शन इन द KC एंड 6 लाइक दैट. forget about this, just pick this line, right, जो k का फंक्शन है, and put this is that this should be greater than 0 for stability, right? This equation must be greater than 0, right? And find out the condition for the Kc. That's it. Okay, done. Is it clear to you? Yes. And also you can solve this question. Just try this question with the help of उससे भी आप ट्राई कर सकते हैं इस क्वेश्चन को. एक बार बोर्डे जो हमने स्टेबिलिटी क्राइटेरियन है उससे भी एक बार ट्राई करके आप देख सकते हैं. ठीक है, डन. इज इट क्लियर टू यू? सो जस्ट सी दैट, सी हाँ, एक इसमें इंपॉर्टेंट चीज और समझिएगा. इफ एनी अनदर एलिमेंट ऑफ द रो इज ऑल्सो कंटेनिंग के, you should also use that term. You should also find the value of Kc, है ना, उसमें भी आपको Kc की वैल्यू निकालनी पड़ेगी for the stable system. And by combining these condition आपको एक वैल्यू बतानी है. लाइक इससे मान लीजिएगा that K must be greater than 1. मान लीजिए C आ गया, Kc must be greater than 1, और इससे आगे आपका Kc must be less than, let's suppose 5. So it is very obvious that Kc must be in between 1 to 5 for the stable system. Is it clear to you? Am I clear with this or not? Please let me know, guys. Am I clear with this or not? Please let me know. Please let me know. So in any element, if you will see the Kc term, apply the stability condition for that, but that all the elements, and find a combined criteria for the stability. Okay, done. हाँ जी, next. So this is also a question जो किसी ने भेजा मुझे, I think किसी टेस्ट सीरीज का पार्ट है, I don't know. See, how to solve these type of questions. Maybe we all guys are think, okay, this क्या इतना बड़ा ट्रांसफर फंक्शन हम कैसे निकाल पाएंगे. There is a huge calculation in this question, है ना. I don't know how we can calculate. ऐसा तो हमने कुछ क्लास में पढ़ा ही नहीं, ठीक है. So make sure guys, गेट में आपको ऐसा कुछ भी नहीं मिलेगा जो आपने पढ़ा नहीं, राइट. जस्ट ट्रस्ट ऑन योर सेल्फ फर्स्ट एंड जस्ट कोशिश करो, ट्राई करो प्रॉब्लम को तोड़ने की कि क्या हो सकता है इसके अंदर, राइट. इनमें आपको एग्जैक्ट ट्रांसफर फंक्शन निकालने की रिक्वायरमेंट नहीं है. देयर इज नो रिक्वायरमेंट टू कैलकुलेट द एग्जैक्ट ट्रांसफर फंक्शन, बिकॉज सी with the help of the graph we can not calculate the exact transfer function, right. ये हमें देखना पड़ेगा ऑप्शंस एलिमिनेट करके. सर कैसे, हाउ, सी जस्ट यूज कॉन्सेप्ट हियर फर्स्ट. यहां पे कॉन्सेप्ट यूज करके देखते हैं. माय कॉन्सेप्ट इज सेइंग दैट see this dashed line is the input, so this is the input, and this bold line is my output, and I can see that at this point input is giving into the system, but I'm getting output after some time. After some time you can see here rise, after some time. Yeah, so it means there is a dead time here. Yes or no? So, and I know the transfer function of the dead time, that is e raised to power minus tau ds. This representation of tau d can be anything. Okay, so first of all there should be a dead time transfer function in the overall transfer function. तो जिसके अंदर, जिस भी ऑप्शन के अंदर डेड टाइम वाला ट्रांसफर फंक्शन नहीं है, सबसे पहले वो एलिमिनेट होगा. यस और नो? सो आई थिंक इन द सी ऑप्शन देयर इज नो e raised to power minus tau ds वाली टर्म. सो फर्स्ट ऑफ ऑल वी नेग्लेक्ट द सी ऑप्शन. बोलिएगा. आई होप दैट आई एम क्लियर टू यू. I hope that I am clear to you. I hope that I am clear to you. बोलिए. I am clear to you or not? I am clear to you or not? Okay. ठीक है. Now, okay, coming to the next part. You can see the response is something. We are getting the response from here and it is going upward to the UVR. This is kind of underdamped system. Means it, देखो, see, ultimately my system is settled at this value. Ultimately the system, my output curve is settled at this value. It means this is my UVR, ultimate value of response. But it surpasses the ultimate value of response and achieving a MVR, maximum value of response. So here we can see overshoot. We can see here overshoot. I hope that this is clear to you. So for sure this is the second order system. ये भी clear हो गया कि second order system है. So there must be a second order type of transfer function must be there. If it is the second order, then we know that in the second order system we are having a response kind of S shape. Kind of S shape. Is it clear to you? Kind of S shape, right? Is it clear to you guys? Yes or no? Okay. ठीक है. So there must be the second order. So in the denominator there must be a square. ठीक है. So this can be the answer और this can be the answer. इन दोनों में अपने पास क्या है? tau 1s plus whole square, tau 2s plus whole square. तो ये भी आंसर हो सकता है और ये भी आंसर हो सकता है, right? Now, if we will see the graph, then I can predict one thing, that this response is something aggressive. The response is aggressive actually. Aggressive means that we, देखो S type में क्या है, S type में we know that second order system is sluggish as compared to the first order. So that graph, the response curve is kind of S shape, means थोड़ा सा sluggish nature इसका दिखाएगा. बट यहां पे आपको दिख रहा है कि ये यहां के बाद में थोड़ा सा मतलब एक हायर स्लोप के साथ में कर्व राइज हो रही है. यस और नो? यस और नो? इज इट क्लियर टू यू गाइस? I can expect this kind of normally in the second order I can expect this kind of curve of the output, but this is the aggressive nature, means the system is fast. Actually this is showing this is the system is fast. Okay, now just do एक यहाँ पे जो important चीज है वो आप ये देख लेना. Previously we have discussed that we can see the inverse response if the zeros are positive. If zeros are positive, it tends to the system is inverse response. What if zeros are negative? What if zeros are negative? If zeros are negative, this means, guys, this basically making your system fast. If any transfer function, if you can see the negative zeros, it means negative zeros making the system fast and it leads to the overshoot. It leads to the overshoot. And if zeros are positive, then it basically gives the inverse response. Is it clear to you? So by this graph, I can predict that system is fast. My response is fast actually, as compared to the normal second order system. So there must be a negative zeros. Okay, zeros means at the value at which my numerator will be 0. So pick first option, alpha s plus 1. Calculate the value of s. S is equal to minus 1 minus alpha. Yeah, so it is my zeros which is negative. Okay, in the D option, it is my alpha s plus 1 whole square is equal to 0, right? Is equal to 0. Okay, right? And see, so zeros are here also in this option. In this option zeros is negative, in this also the zeros are negative, है ना? So अभी भी हमें क्या लग रहा है? अभी भी हमें लग रहा है कि maybe the option can be A or the option can be D. Now how to choose between A and D? See, this जितने आपके zeros negative होते जाएंगे उतने ही सिस्टम की फास्टनेस इंक्रीज होती जाएगी. ठीक है, ये हम एक नई बात पढ़ रहे हैं, बेशक से इसको लिख लेना है आप कहीं पे. जितने भी जीरोज नेगेटिव जीरोज आपके इंक्रीज होते जाएंगे, सिस्टम की फास्टनेस उतनी ही इंक्रीज होती जाएगी. इट मींस दिस सिस्टम मस्ट बी फास्टर एज कंपेयर टू दिस, राइट? बट वी कैन सी दैट सिस्टम इज फास्ट तो है बट थोड़ा स्लगिश भी है. Means if a alpha plus 1 whole square will be there, then this kind of response I can expect from this. A very fast system as compared to this. Am I clear with this or not? Am I clear with this or not? Please boliye. So the A will be my correct option. A will be my correct option. So I can make a statement here that poles make the system sluggish, ठीक है, and negative zeros make the system fast. Okay, हाँ सर, y b is eliminated, denominator is second order here also. Very good. ठीक बात है, बिल्कुल सही बात है। यस, बी कैन बी द ऑप्शन, हो सकता है। एंड डिनोमिनेटर इज थर्ड ऑर्डर इन ए एंड डी। देखिए, सो वी स्टडीड अ टू सिस्टम, इफ यू रिमेंबर, ठीक है, जो मुझे समझ में आ रहा है अभी। वी हैव स्टडीड टू सिस्टम, इंटरैक्टिंग सिस्टम एंड नॉन इंटरैक्टिंग सिस्टम, if you remember, right? And what is the difference between non-interacting and interacting? The difference between the interacting and non-interacting is in the non-interacting system, you will find only you just find the multiplication of those two individual transfer functions. That's it, right? So there is no interaction term there, है ना? There is no interaction term there, right? So this is my non-interacting system. This is my non-interacting system, right? ठीक है. And this must be the interacting system. Okay, right? So and we know that non-interacting system is faster as compared to the non-interacting system. Interacting systems are the non-interacting systems are the faster as compared to the interacting system. And in the non-interacting system, the total transfer function is only the multiplication of the individual transfer functions. So here we can see that this is the multiplication of the individual transfer functions, right? So this makes the function even more fast as compared to this, because here also negative zeros are there. Also this is a non-interacting system, so even this system is also more this system shows the more fastness as compared to the other transfer function, means the non-interacting functions. ठीक है, क्या बोल सकते हैं हम, ये बताइए, प्लीज लेट मी नो, क्या बोल सकते हैं? आई थिंक दिस कैन बी द रीजन, और अभी भी कोई डाउट है तो इसको हम देख लेंगे बाद में, डोंट वरी, फिर से एक बार इसको रीचेक कर लेंगे हम, ठीक है, क्योंकि ज्यादा समय हम स्पेंड नहीं कर सकते किसी एक प्रॉब्लम पे, बट मुझे लग रहा है कि यही रीजनिंग हो सकती है इसकी, बट स्टिल वी कैन चेक दिस, ठीक है, इसकी डिटेलिंग और हम चेक कर सकते हैं, बट आई थिंक दिस कुड बी द रीजन। चलिए, ओके, एक ये प्रॉब्लम आई मेरे पास में, काफी लोगों ने मुझे प्रॉब्लम भेजी, सो जस्ट प्लीज रीड दिस प्रॉब्लम एंड आई विल एक्सप्लेन इट। फर्स्ट ऑफ ऑल, रीड दिस प्रॉब्लम। कंसिडर द टैंक लेवल कंट्रोल सिस्टम, मीन्स वट एवर द कंट्रोल सिस्टम यू see here, this is the level control, means this is the any tank and we have to maintain the level of this tank. Okay, and where the cross section area of the tank is A, and assume perfect flow controller. Perfect flow means, what is the meaning of perfect flow? Perfect flow means that we are getting any constant flow rate. We are getting the constant flow rate here. Okay, perfect flow means at a particular value we are getting the flow. The level controller LC is PI controller, so this is PI, and for an integral time tau1 is the level controller gain, ठीक है, integral tau I case is the gain, ठीक है, is tuned for critical damping. This is called critical damping. If critical damping is there, we know the what can be the value of the zeta. In that case, we have to calculate the value of Kc tau I over A. This is the question actually. This is the question actually. Okay. Now this is a perfect flow, means at this point we are getting any constant discharge. So can I say this is a pure integrator function? We discussed so many type of transfer function, if you remember, in which we have discussed a kind of transfer function, that is जो हमारे पास में क्या आ रहा था, this kind of transfer function we are getting. If you remember, this transfer function is equal to 1 over as, if you remember this, and after that I call you that 1 by a is your kp and all that, like that, right? याद है सबको? Please tell me that you remember this or not. That is a pure integrator function, right? Pure integrator function हमने उसको माना था. Okay, means there is only the capacity, not resistance, kind of, right? So what is this? What is the transfer function? Transfer function is output is my maintaining the height divided by the discharge, flow rate is equal to 1 divided by as. This is my process transfer function. PI controller is here. Are we able to write the PI controller transfer function? PI controller transfer function, are we able to calculate the PI transfer function, guys? बोलिएगा. So for the transfer function of the PI is equal to Kc into 1 plus 1 divided by tau is. I think this is the transfer function for the PI controller, if I'm not wrong. ठीक है, प्लीज लेट मी नो, बिकॉज मुझे फॉर्मूलाज ध्यान नहीं रहते. अगर कोई गलती है तो प्लीज मुझे बताएं. इट इज माई Kc इंटू टाउ आई एस प्लस 1 एंड डिवाइड बाई टाउ आई एस. दिस इज माई ट्रांसफर फंक्शन ऑफ द PI कंट्रोलर. डन? क्लियर? ओके, सो I think there is चलिए पहले इतना बताइए, इतना डन है सबको? This is clear or not? This is clear or not? And here we can see that the controller and the process, this is my process now, my controller and the process is in the open loop. There is no closed loop here. So can I write the transfer function of the open loop? Can we write the open loop transfer function? Yes. Just multiply the transfer function Gp and G for the PI. What is the Gp? 1 divided by As, and it is my Kc into tau is plus 1 divided by tau is. This is my open loop transfer function. Okay. Done. One second, guys. One second. This is my. This is my no. This is closed loop actually, not open loop. Closed loop. गलती से मैं open loop बोल गया. Because this is my output and this is basically the control. हाँ, ये वही वाली तो problem है. यहाँ से हमने measurement लिया, कंट्रोलर में गया, कंट्रोलर ने फाइनल कंट्रोल एलिमेंट को बोला और फाइनल कंट्रोल एलिमेंट ने फिर कंट्रोल वॉल्व को सिग्नल दिया. राइट? क्लोज लूप, नॉट ओपन लूप, क्लोज लूप. ठीक है, क्लोज लूप. डन है यहां तक? प्लीज एक बार बताएं मुझे, यहां तक डन है? किसी को कोई दिक्कत? यहां तक किसी को कोई दिक्कत है? प्लीज लेट मी नो. ओके, व्हाट, दिस इज माय ओपन लूप ट्रांसफर फंक्शन. ठीक है, ओपन लूप निकाल लिया तो चलो क्लोज लूप निकाल लेंगे इसकी हेल्प से, कोई दिक्कत नहीं है. क्लोज लूप क्या आएगा मेरे पास में? व्हाट कैन बी द क्लोज लूप ट्रांसफर फंक्शन? If we need the characteristic equation for the closed loop transfer function, if we need the characteristic equation for closed loop transfer function is my 1 plus OLTF, है ना, यहाँ यूज कर लेंगे, is equal to 0. Am I clear with this guys? Please let me know. We already calculate the open loop transfer function. that is my 1 by as into kc into tau I s plus 1 divided by tau is equal to 0. I think this is the okay. Done. Right. Okay, now just open the bracket. It is my a tau I s square, a tau I s square plus kc tau I s plus kc is equal to 0. Yes or no? This is my characteristic equation. Please let me know if I made any mistake. This is my closed loop characteristic equation. This is my characteristic equation. Or you can say the denominator or characteristic equation. If I made any mistake, please let me know. अगर मैंने कहीं गलती कर दी हो तो मुझे बताओ, अदरवाइज थोड़ा आगे बढ़े हम. काफी लंबा चला गया डिस्कशन आईपीसी का भी. चलिए कोई बात नहीं. डन. सब के सब, सिर्फ अनुष्का ही नहीं, बाकी लोग भी करो रिप्लाई, ताकि मुझे पता लगे कि हाँ ठीक है. क्योंकि सिर्फ देखिए मैं ऑनेस्टली बताऊं आई डोंट हैव टाइम गाइस. मैं आई एम स्टक समवेयर एंड सिर्फ आप लोगों के लिए, क्योंकि अनुष्का ने काफ़ी क्वेश्चंस भेजे हुए हैं, महीना ने भी, है ना, किया, काफ़ी लोगों ने भेजे, और मुझे लगा कि चलिए ठीक है, कुछ चीज़ों को एक बार असाइड किया जाए. आप लोगों का पेपर है तो मैंने अपने जो पर्सनल चीज़ें थी उनको एक बार असाइड करके और जो है आपके पेपर को प्रायोरिटी भी रखा है. तो रिप्लाई तो कर सकते हो यार, है ना, सो दैट हम थोड़ा फास्ट चले, और कुछ वो नहीं है, थोड़ा फास्ट चलेंगे और कुछ नहीं है. हाँ जी, दिस इज माई कैरेक्टरिस्टिक इक्वेशन, राइट. और यू कैन से द डिनोमिनेटर ऑफ द ट्रांसफर फंक्शन. यस, इज इट क्लियर टू यू? Let's make this transfer function in the form of this is s square. It means that my transfer function is of the second order transfer function. Second order system का transfer function है मेरे पास में. Okay, do one thing, just make this transfer function similar to the general form. By dividing kc, I have a tau I divided by kc s square plus tau I s plus 1 is equal to 0. राइट, दिस इज माई सेकेंड ऑर्डर टाइप ऑफ ट्रांसफर फंक्शन, है ना. तो यही तो होता है ना, केपी डिवाइड बाई क्या होता है मेरे पास, केपी डिवाइड बाई व्हाट इज द डिनोमिनेटर, टाउ पी स्क्वायर एस स्क्वायर प्लस 2 जीटा टाउ पी एस प्लस 1, राइट. सो वी हैव टू कंपेयर विद दिस. ओके, व्हाट इज माई टाउ पी? माई टाउ आई स्क्वायर इज इक्वल टू, my tau square is equal to a tau I over kc. Okay, 2 zeta tau is equal to tau I. I hope there is no problem. I hope that there is no problem with this. I just compare the transfer function with the second order, right? Clear है इतना? Done? Question is saying that the system is critically damped. Critically damped means if the system is critically damped, guys, then my zeta value is equal to 1. Put here, then my tau is equal to tau I divided by 2. Put here, zeta is equal to 1, my tau is equal to tau I. Okay, now this equation, because I need this value, na? I need this kc tau I a value, means kc tau I a value, this kind of value I have to calculate. Tau square is equal to a tau I divided by kc. What is the tau I? Tau I is my tau I by 2, so it is my tau I square divided by 4 is equal to a tau I divided by kc. 1 tau I cancel, and I need the value kc tau I a. So kc उधर गया, kc tau I divided by this a, and this 4 goes that side, this is equal to 4. So kc tau I divided by a is equal to 4. So answer is 4. I don't know that what is the answer, but yeah, ये मेरा आंसर है. आप जिसका भी क्वेश्चन था एक बार मैच कर लीजिएगा क्या है इसका आंसर. So this is the value of this ratio. This is the value of this ratio, guys. Please let me know that this is clear to you or not. Okay. So problem is you can say whatever the concept we used, we already studied it, like what is the critically damped, what is the transfer function and all that. We know this, right? Just only the thing is how we implement this. That's it. How we implement this. This is the only thing. Okay, चलिए. Okay, ये हम बाद में करते हैं, पहले इस पे आइए. कुछ क्वेश्चंस जो हैं आईपीसी में आए हुए कुछ क्वेश्चंस जो हैं, दैट इज टोटली द फैक्चुअल यू कैन से क्वेश्चंस, है ना. मुझे एक दो स्टूडेंट्स ने ये भी बोला कि सर मैं एक क्वेश्चन अगर मुझसे नहीं आता है तो मैं घबरा जाता हूँ, आई लूज माई सेल्फ कॉन्फिडेंस, है ना. सो यार पहली बात तो ये है कि आज तक हिस्ट्री में केमिकल इंजीनियरिंग में खासकर 100 आउट ऑफ 100 कोई नहीं लेके आया है. ठीक है, 100 आउट ऑफ 100 कोई नहीं लिखा है. इवन रैंक 1 कैन नॉट अचीव द 100 आउट ऑफ 100. ठीक है. सो इट मींस देयर आर सम क्वेश्चंस जो हमें ड्रॉप करने होते हैं. ठीक है. सो वो क्वेश्चंस भी वो ऐसे ही जानबूझ के बनाए जाते हैं ताकि स्टूडेंट्स उनको अटेम्प्ट ना कर सके. ठीक है. तो मैं क्या बता रहा हूं ये कि कोई अगर आपने एक आधा ऐसा क्वेश्चन देखा जो आपको लगा कि यार ऐसा तो कुछ हमने पढ़ा ही नहीं, इसका मतलब है कि वो सबके लिए ही क्वेश्चन नया है. डोंट वरी अबाउट दैट क्वेश्चन. ठीक है. जस्ट अटेम्प्ट द क्वेश्चंस जो आपको आते हैं, जो आपने पढ़ा है, और वो मेजोरिटी में वही मिलेंगे आपको. 95% ऑफ द पेपर यू विल सी दैट इज अराउंड द प्रिपरेशन, अराउंड योर प्रिपरेशन. ठीक है. 5% वो क्वेश्चंस ऐसे ही डालते हैं हर सब्जेक्ट में जो किसी से सोल्व ना हो. ठीक है. ऐसे कुछ क्वेश्चंस दिए उन्होंने, जैसे कि अलग अलग क्वेश्चन जो आपके आए मेरे पास में, जैसे कि ये वाला क्वेश्चन है, द बायस वैल्यू फॉर द टू कंट्रोलर्स सो दैट नो ऑफसेट अकर इन द ईदर कंट्रोल. दिस इज द कंप्लीटली फैक्चुअल बेस्ड क्वेश्चन. फैक्ट है ये, एक बुक में लिखा हुआ है कि नो ऑफसेट के लिए बायस वैल्यू क्या रखना है. चलिए ना, इस क्वेश्चन से हम क्या सीख सकते हैं, लेट्स ट्राई टू फिगर आउट. फर्स्ट ऑफ ऑल वी शुड नो द मीनिंग ऑफ बायस वैल्यू. व्हाट इज द मीनिंग ऑफ बायस वैल्यू एक्चुअली. चलिए, see, so generally we are saying that okay, that this is your system and this is the input, this is the measurement, and this is going into the controller, this is the set point. Let's suppose this is the final control element, right? And this is opening this wall and all that, right? So this is my process variable value. Okay, now let's suppose temperature, and this is my set point. Temperature is my process variable. So I'm saying that my process variable is, let's suppose 80 degree, and let's suppose I feed the set point is also 80 degree. In general way क्या बोलते हैं हम, if my process variable is equal to the set point, यहाँ पे measurement भी क्या जाएगा, 80 ही जाएगा, means error 0. So in general way we call it like that, if error is 0 then controller will not take any action. ये बोलते हैं ना, controller will not take any action if error is 0. Or we can say if my process variable value is equal to the set point, then controller will not take any action. Really this system is this statement is technically correct? No, this statement is technically is not correct. This is the any layman language. ठीक है. ये हम ऐसे ही बोल सकते हैं कि ओके एरर इज इक्वल टू 0, कंट्रोल विल नॉट टेक एनी एक्शन. हम ये क्यों बोलते हैं, ताकि स्टूडेंट के दिमाग में ये फीड हो जाए दैट कि एरर अगर 0 है तो जो जिस ओपनिंग पे मेरा वॉल चल रहा है, कूलिंग वाटर वॉल, वो उसी ओपनिंग पे चले, देयर इज नो नीड टू चेंज एनीथिंग। बट जिस भी फ्लो रेट पे वो चल रहा है, let's suppose a scenario where my process variable is equal to my set point, and at this value there is some particular opening of the cooling water wall. Who maintain this particular opening of the wall? Controller. So we cannot say that controller will not take any action. Yes or no? Controller always means कि वो हमेशा ही एक्शन में रहता है ना? Controller will always be on its work. So who maintain that particular flow rate? Controller. Yes or no? Is it clear to you? So bias value is something, and when error is zero, then the controller, if error is zero, controller कुछ तो दे रहा है ना, कुछ तो आउटपुट दे रहा है ना, controller is giving some output. That is my bias value. Actually, that is my bias value. Let's suppose the wall is 50% is open. 50% wall is open when my process variable value is equal to set point. So this 50% wall कैसे खुला? This is the output of my controller. So 50% is my bias value. This is my bias value actually. Is it clear to you? Is it clear to you guys? Is it clear to you? I hope that this thing is clear to you. बोलिएगा, समझ में आ रही इतनी बात मेरी? This is clear to you or not? Please tell me. Okay, done. Now this is, we already studied the cascade thing, na? We already studied the cascade thing. So what do you think in the cascade control? What do you think? Then see, एक होता है in the cascade controller, there are two type of controller in which we studied the primary control, secondary control, है ना? Likewise, one term is called master control and another is the slave control. Master control or slave control. Master means that it means that the whole scenario is handled by the master, and slave control is only taking the instruction from its master. So there are two kind of controller we have, right? There are two control system we have. Okay, one is your like flow controller, which basically जैसे कि लास्ट वाले एग्जांपल में ही था, this one, this is my flow controller, right? So my flow controller and another flow controller and another controller is my pressure controller. What do you think, guys? With the help of flow controller we maintain the pressure, or with the help of pressure we maintain the flow? So I think all guys are you can say that satisfied with this statement, that with the help of pressure we maintain the flow controller. With the help of pressure we maintain the flow. Yes or no? So this is my master control and this is my slave control. Always. ठीक है? Is it clear to you? Done? So with the help of this pressure and the flow, we are maintaining our desired value. Okay, right? Is it clear to you? So like if my process variable is equal to set point, if my process variable is equal to set point, it means that whatever we fed the set point, we achieved that process variable. It means the offset is 0. यही तो मतलब होता है ऑफसेट का. इट मीन्स ऑफसेट इज माई जीरो. यस और नो? My set point, my process variable is achieved. Whatever we want to achieve, we achieve that. We achieve that R. That offset is equal to 0. Right? So in that condition, the value of the PC and the value of the SP, whatever we feed in the pressure control and whatever you feed in the flow controller, these are, we have two values जो हमने set करनी होंगी. So that if we set these values, then my offset will be 0, है ना. और जो हमने values डाली हैं, that is a bias value, because bias value is calculated at the offset 0. Right? Is it clear to you? So इस condition में, in this condition, we choose the bias value, which is basically in the inverse proportion. So the PC is inversely proportional to the FC. ऐसे proportion में रखी जाती है. Means if we have to, it means that if I keep PC value low, then FC value high. PC value low, then FC value high. It means at the lower pressure signal, flow will be high. और यही होता है. You know that. Is it clear to you? Is it clear to you? Right? So PC value keeping low and my FC value will be high. So ये inverse proportion maintain किया जाता है. These are the only factual things जो मैं आपको बता रहा हूं. ठीक है. So first of all, whatever we have the option, in that option, अगर ये bias value का offset 0 वाला कुछ ऐसा क्वेश्चन आता है, तो ये इंफॉर्मेशन आप ध्यान रखेंगे. That what is the master control, what is the slave control, and at offset 0 we feed some values in the PC and we feed some value in the FC. And the value of PC and the FC are in the inversely proportional. Means at the lower pressure signal, my flow controller will be high. My flow controller will be high. Like if temperature is increasing, my temperature is increasing, then the cooling water flow will be high. For that, my pressure signal must be low, because that the relation is basically inverse. So PC must be keeping at lower value and FC must be keeping at the higher value. Now just choose options. So PC 40, flow 60, सही लग रहा है. PC 33, flow 67, ठीक लग रहा है. PC 67 and flow 33, ये गलत लग रहा है. Why? Because PC we must, in this condition, PC maintained at the lower value. Also, the D option is also incorrect. So the you can say correct option can be A and B. Now this is basically already, it is given in the book on the you can say on the factual basis, that in this type of condition, pressure controller will basically maintained at the 33% and flow controller will maintained at the 67%. It is the experimental value which basically it is predefined. Means ये value रखी जाती है literature को देखते हुए, for biasing value रखी जाती है for no offset. I hope that this is clear to you, right? So yeah, I can tell you that only the factual information. Okay, just remember 33 to 67. That's it, है ना? बजाय इसके, I tried that around this, whatever the concept, whatever the information I can give to you, वो हम discuss करें. Is it clear to you guys? Can we move forward? बोलिए जल्दी से. Can we move forward? Okay, now see the next question. Next question. See, okay, just please read out the problem carefully. एक बार इस problem को अच्छे से पढ़ेंगे. What problem it's saying? Okay, see. So the question is saying guys, we have two systems. पता नहीं आप में से किसी ने भेजा और ये इसके ऑप्शंस भी नहीं दिए मुझे सारे, यहीं से क्रॉप कर दिया इसको। चलिए कोई बात नहीं, देखो क्वेश्चन भेजो तो बेटा इसको प्रॉपर एक मतलब सारे ऑप्शंस दिखाया करो मुझे क्या है क्या नहीं है। देखिएगा, we have two systems, system 1 and 2. The important things are flow transmitter is direct acting. This is the flow transmitter. This is the flow transmitter. And in the transmitter, what is the meaning of direct acting? It is already given to us that output increases as the actual flow rate increases. Okay, means it is saying that Ft is direct acting. Okay, so this is my Ft and Ft is direct acting. So this is my input and this is my output, and it is direct acting. So output increases as the actual flow rate. Flow rate means if its input increasing, its output is also increasing. Okay, and this is saying that this is the valid for both the case, means Ft यहाँ पे भी direct acting है, यहाँ पे भी direct acting है. Now, however, the control valve in the system 1 is air to open, means in this system, this is air to open. Okay, means if air signal increasing, it is flow is also increasing. If air signal decreasing, it is also decreasing. Is it clear to you? It is clear to you, yes or no? Means wall क्या है? Air to open. Air to open. Air to open means air signal increasing. Air signal means if its input is increasing, it is open. So it is output is also increasing. Yes or no? Yes or no? Is it clear to you? Is it clear to you? And this is all about the system 1. This is all about the system 1, right? So I hope that you basically remember this, that output is nothing but its gain and input. है ना, यही था ना हमारे पास में, the relation between the gain and output and input. यही output is equal to gain into input. So see, if let's suppose the gain value is positive, then if I increase the input, my output is also increasing. Let's suppose its gain is negative, then if I increasing input, my output will decrease. So by increasing input, if my output is increasing, it means its gain is positive. Yes. So in this wall, in the system 1 wall, if this is increasing function, it means what is the gain of the wall? kV. So kV के लिए system 1, it is for system 1. For system 1, my Kc value is greater than 0. It means it is positive. It is positive. Is it clear to you? Is it clear to you? Yes or no? Yes or no? बोलिए. Now let's calculate about the Kc. Kc is for the controller. Okay, it is further saying air to open, meaning that increasing pressure signal, controller will open more. ठीक है. Thus, the increasing flow rate. Okay. On the other hand, the control valve in the system 2 is air to close. So this is air to close, right? Then the dynamics. Okay. Now see. So सिस्टम 1 के अंदर वॉल्व एयर टू ओपन है, मींस इफ कंट्रोलर आउटपुट, अब यहां से देखेंगे हम, कहां गया, अबाउट दिस ना, मींस इफ कंट्रोलर आउटपुट इज इंक्रीजिंग, this control valve will also open and its output also increasing. Is it clear to you? ठीक है. And Ft is what? Ft is your direct acting. It means, let's suppose if my liquid flow rate is increasing, Ft is also this kind, that it also giving the feedback to the controller increasing. What we have to do, we have to maintain the flow rate at the desired rate. Let's suppose suddenly the liquid flow rate at this point is increasing. because my FT is direct acting, it gives the increasing signal to the flow controller. Let's suppose my flow controller is direct acting. Let's suppose direct acting, then it is, if it's direct acting means if it gains the increase input, it also giving the increase output. So flow controller will give the signal to the control valve that open the valve, right? So FC also send the increase signal. That increase signal going into the valve, because valve is air to open, so this valve open the more, this valve will open, this valve going to be open more, yes or no? So हमें क्या करना था, लिक्विड के फ्लो रेट को मेंटेन करना था. बट इफ आई कीप दिस सिनेरियो, दिस इज प्रीडिफाइंड, बट इफ आई FC is, if I am keeping FC is direct controlling, then by increasing flow rate in the liquid, it is also क्या होगा कि ये और इसको फ्लो रेट को क्या कर देगा, ज्यादा कर देगा. It disturbed more. Okay, do one thing, इसको indirect रखते हैं. Indirect means that FC is the input of the FC is increasing, then due to this indirect acting, my output will be decrease. If my output will decrease, that the valve will basically going to close and I maintain the desired value. So my flow controller value will be decreasing. Means if my input is increasing, output will be decreased. It means its gain must be negative. Its gain must be negative, yes or no? So its Kc must be negative. Is it clear to you guys? Is it clear to you how I choose the value? I hope that this is clear to you. So just keep दोनों ही सिनेरियो लेके चलो आप, कोई प्रॉब्लम नहीं है ना? बस जस्ट आप देखो कि आपका डिजायर क्या है, व्हाट इज आवर आउटपुट. According to that, choose the action. Okay. Now, in the system 2, my wall is air to close. This wall is air to close. It means if air signal is increasing, it will decrease the flow rate. Yes or no? Is it clear to you? So it is air to close. So it means there is a opposite relation in input and output. So this control valve for system 2, control valve gain will be negative. ये negative होगा. Now what about the FC? FT is already pre-decided that it is a direct acting. Let's suppose my flow rate is increasing. FT is also giving the increase signal. So FC, if FC is my indirect acting, let's suppose, then its input is increasing, so it giving the less signal. If it is giving the less signal, my liquid flow rate will be more. So this is not desirable condition. So what is a desirable condition? Desirable condition is FT is indirect acting. So if flow rate is increasing, it gives the increased signal. If my FC is direct acting, then it gives the increased signal. That increased signal basically is helpful to decrease the flow rate, because it is the air to close valve. So my FC must be the direct acting. So input is increasing, output is increasing. In that case, what will be the gain? Gain will be the positive. So its Kc will be positive. Kc will be positive. So this is for the system 1 and this is for the system 2. I hope that this is clear to you. Is it clear to you? Right? इसका मैंने आपको क्लास में एक शॉर्टकट भी बताया था. सी, अगर टाइम है, ऐसे समझ के कर सकते हो, डू दिस, डोंट वरी, कोई बात नहीं है. अदरवाइज मान लो टाइम नहीं है, समझ में नहीं आ रहा क्या है क्या नहीं है, जस्ट follow one thing. If wall is your air to open, in that case what must be the controller? And if your wall is air to close, in that case what could be the controller? Is it clear to you? So if it is air to open, just remember, just keeping the reverse acting controller. Reverse acting controller means increasing input, decreasing output, gain negative. Right? And if it is air to close wall, then it is the direct acting. Direct acting means increased input, increased output, gain is positive. Just follow this. That's it. ज़्यादा दिमाग मत लगाओ, है ना, ज़्यादा दिमाग मत लगाओ. Clear? Done, guys? Can we move forward? Please बोलिए. Can we move forward, guys? Okay. चलिए देख लीजिए. Control valve characteristic is selected such that the product of process gain and valve gain. वही वाली बात आ गई. Process gain means the controller part and the valve gain is your valve वाला part, right? Your valve वाला part. So don't worry. देखो, see what is my main motto of installing the hardware element like controller and the valve. My main aim is to basically remains my output value must be the output value must be at the constant value, है ना, constant रहना चाहिए. Right? Is it clear to you? Yes or no? मान लीजिए कि कोई भी फ्लक्चुएशंस आती हैं, उस फ्लक्चुएशंस के साथ में अगर मेरे पास आउटपुट में भी मेरे पास में फ्लक्चुएशंस आ रही हैं, दैट विल बी माय बैड थिंग फॉर मी. यस और नो? सो द प्रोडक्ट मस्ट बी द रिमेन्स कांस्टेंट एज द वैल्यू ऑफ मैनिपुलेटेड वेरिएबल चेंजेस, राइट? सो कंट्रोलर वेरिएबल जो है आपका, सी दिस इज द कंट्रोलर गेन एंड दिस इज द वाल्व गेन. इफ देयर इज एनी fluctuations is basically coming into the system, control will take action. According to that, it change the manipulated variable. What is the manipulated variable? Flow rate of the control valve, right? But ultimately, if manipulated variable changes, okay, ultimately what we want that my ultimate value, my process variable remains constant. Yes or no? Is it clear to you? So that value must be remains constant. This question wants to say. ठीक है? ओके, चलिए ये और देख लेते हैं. क्वेश्चन क्या कहता है? लिक्विड फ्लोइंग थ्रू अ हीट एक्सचेंजर is heated. A bypass stream is provided to control the temperature. So this is the heat exchanger, right? And this is the bypass stream we are having to control the temperature, of the heated exit stream. Means we want to control the temperature of this exit stream, right? For that purpose we just installing a bypass stream. From a given plumbing option, the one that provides the most effective temperature control for large disturbance while avoiding the vaporization in the heat exchanger. Means that we ensure that vaporization must not occur. Also we need for the large disturbances there must be a temperature, there must be a good temperature control at the exit of the stream. Okay. So simple इसका मतलब ये है कि heat exchanger में liquid heat हो रहा है. There is a heating of the liquid in the heat exchanger. And for the temperature control there is a bypass line. Yes, we have to use a bypass line for the controlling the temperature, right? Is it clear to you? Ensuring that heat exchanger के अंदर vaporization नहीं होनी चाहिए. Right? Is it clear to you? ठीक है? So just remember one thing guys. बेस्ट बाईपास टेम्परेचर कंट्रोल कब होगा? बोलिए. बेस्ट बाईपास टेम्परेचर कंट्रोल कब होगा? सो इफ द फ्लो रेट इज माई कांस्टेंट, सी इफ basically faces a large disturbances. कभी लिक्विड बहुत ज्यादा फ्लो रेट से आया, कभी बहुत कम आया, है ना. लेट्स सपोज द फ्लो रेट ऑफ द कमिंग स्ट्रीम इन द हीट एक्सचेंजर इज वेरी लार्ज, कभी कम हो रहा है. दैट विल डिस्टर्ब इट्स टेम्परेचर, दैट विल डिस्टर्ब इट्स इक्विलिब्रिया. यस और नो? सो वी वांट दैट द फ्लो रेट in the heat exchanger must be constant. Yes or no? Is it clear to you or not? Whatever we control through the bypass stream only. Whatever we control, that we control through the bypass only. Yes or no? Is it clear to you? Is it clear to you? What control valves do? Control valves basically the main function of the control valve is decreasing the pressure. Decreasing the pressure, yes or no? So first of all we want that at the inlet and the outlet there will not be a control valve in the heat exchanger. Inlet पे और outlet पे control valve नहीं हो, ठीक है, control valve उसके ऊपर नहीं हो. Because due to the pressure difference there may be a chances of the flushing, boiling, that is called vaporization. There may be a chances due to the pressure difference. चलिए ऑप्शन ए को चेक करते हैं. In the option A there is a control valve at the outlet of the heat exchanger that suddenly drop the pressure. And there is a risk of the vaporization, right? So we cannot take the option 1. Just check the B option. At the B option there is a control valve at the inlet. Again we want that there must not be we want that a constant flow rate is coming. A constant flow rate is coming towards the into the heat exchanger. Yes or no? Is it clear to you? ठीक है. If I check the option C, in the option C there is no outlet valve here. And the exit stream is going here, and see the control valve is here and the bypass stream is entering after this control valve. Yes or no? Is it clear to you guys? So through this valve I maintain the flow rate at this junction point, and there is no control valve at the exit of the heat exchanger. So there is less chances of the your pressure drop के चांस नहीं होंगे यहाँ पे, तो फ्लशिंग के चांस नहीं होंगे. तो मोस्ट इफेक्टिव हमें सी ही लग रहा है ना. डी तो वैसे ही एग्जिट के ऊपर कंट्रोल वॉल लगाने कोई सेंस ही नहीं है, राइट? इज इट क्लियर टू यू? सो डी इज ऑल्सो नॉट गुड. सो सी इज मोर इफेक्टिव एज कंपेयर टू ए, बी एंड डी. सो देर आर, यू कैन से अगर आप पॉइंट्स लिखना चाहो तो आप ये लिख सकते हैं, देयर मस्ट बी नॉट द कंट्रोल वॉल एट द इनलेट एंड एट द आउटलेट. ठीक है, बिकॉज ड्यू टू द प्रेशर ड्रॉप देयर इज अ चांसेस ऑफ द वेपराइजेशन. ठीक है, बस ये इंश्योर कर लो, बिकॉज वी वांट दैट हाँ जी, we want that pressure is only maintained with the help of the bypass stream, not with the help of the control valves and all that. Done? बोलिएगा. तो बस ध्यान रहे कि टेम्परेचर हमें कंट्रोल करना है विद द हेल्प ऑफ बाईपास ओनली, नॉट विद द हेल्प ऑफ कंट्रोल वॉल. जस्ट वन लाइन इज इनफ. इसी लाइन से आप सारे ऑप्शंस चेक कर सकते हैं. ओके, नाउ ये क्वेश्चन भेजा मुझे. चलिए देखिए, इस क्वेश्चन को भी देखते हैं क्या है. ये क्वेश्चन आई थिंक मैंने डिस्कस किया था क्लास के अंदर, बट चलिए स्टिल करते हैं, कोई बात नहीं. देखो, so question is about considering the control structure. Consider the control structure for the overhead section of a distillation column. ठीक है, the composition control CC means this is This is about to controls the heavy key impurity, means it is heavy key impurity control कर रहा है in the distillate. Okay, in the distillate, right? This is the distillate. By adjusting the set point of the reflux flow controller, है ना, यहां से सिग्नल गया है आपका और ये फ्लो कंट्रोलर है, इसका सेट पॉइंट ये विद द हेल्प ऑफ सीसी चेंज हो रहा है. द साइन ऑफ द कंट्रोलर गेन फॉर द प्रेशर कंट्रोल पीसी एंड दैट ऑफ कंपोजिशन कंट्रोल आर. ठीक है, सो पहले समझो. नाउ जस्ट ट्राई टू अंडरस्टैंड व्हाट इज द प्रॉब्लम फर्स्ट. सो माय प्रेशर कंट्रोल, माय पीसी, दिस इज माय पीसी, this is my PC, yes. So PC is my this is used to control the pressure, right? And this AC, this is my AC, which is my air to close valve. So PC कंडेंसर के ऊपर वाली जो AC वॉल है, ये जो AC वॉल है, इसको मैनिपुलेट करेगा. देखो ये सिग्नल यहां जा रहा है ना, ये बेटा ने ना बड़ा अजीब सा डायग्राम भेजा है मेरे को, दो फोटो में, मैंने दो फोटो को जोड़ा है. ठीक से भेजा करो बेटा, ऐसे मत भेजा करो. दिस पीसी इज बेसिकली मैनिपुलेट दिस एसी, है ना, इस वॉल को मैनिपुलेट करेगा पीसी. पीसी का जो भी आउटपुट होगा दैट विल मैनिपुलेट द एसी, राइट? दैट दिस योर एयर टू क्लोज वॉल. ओके, इज इट क्लियर टू यू? डन. एंड AC क्या है आपका? दिस एयर टू क्लोज. एयर टू क्लोज मीन्स दैट इफ प्रेशर सिग्नल इज इंक्रीजिंग, आउटपुट विल डिक्रीज. यही तो है. इट विल गोइंग टू क्लोज. यस. ओके, नाउ टॉक अबाउट द CC. व्हाट इज द CC? दिस इज द CC. सी, सो CC क्या कर रहा है? CC इज बेसिकली मेंटेनिंग द हैवी डिस्टिलेट में हैवी इंप्योरिटीज को कंट्रोल कर रहा है. यस, इट इज CC इज बेसिकली टेकिंग केयर ऑफ द हैवी की इंप्योरिटी इन द डिस्टिलेट. यस, इज इट क्लियर टू यू? सो दिस इज माय डिस्टिलेट एंड दिस इज माय stream which is you can say going into the distillate again, that is called L. This is going L. So what amount of L is going through this wall, that is decided by this, the flow of this control wall is decided by this FC. How much L is going into the distillation column, how much L is going into this distillation column is decided by this flow controller. This flow controller will increase or decrease the flow rate, yes or no? And this flow and the set point in this flow controller is decided by this CC. Is it clear to you? इसका मतलब है, tell me guys, if the amount of heavy impurity is increasing, then reflux must be decreasing or increasing. Reflux ratio जो है आपका, reflux जो stream जा रही है आपकी, ratio छोड़ो, reflux जो जा रहा है, that will be increasing. That is that should be increasing or decreasing? बोलो. If we are getting heavy impurities in the distillate, if we getting the heavy impurity in the distillate, then reflux must be high or low. Reflux must be high or low. Increasing. Very good. ठीक है, डन है. इतना डन है. यस, गुड. इट मस्ट बी इंक्रीजिंग, राइट? ओके, इट मीन CC टेकिंग केयर द, क्योंकि CC को पता है D में क्या हो रहा है. यस और नो? CC हैज द इंफॉर्मेशन दैट इन द डिस्टिलेट व्हाट इज द हैवी की इंप्योरिटी अमाउंट. इफ इट इज इंक्रीजिंग, heavy impurity is increasing, then CC adjust a set point and that giving the signal to the FC, okay, increase the flow rate, so that L must be high. L must be high. If I'm getting the low, you can say heavy, then it is okay, then it is close, then okay, प्रोडक्ट को आप डिस्चार्ज कीजिए, वापस से इसको डिस्टिलेशन कॉलम में डालने की आवश्यकता नहीं है। राइट, नाउ लेट्स टॉक अबाउट द पीसी। सो पीसी क्या कर रहा है, लेट्स सपोज दैट प्रेशर इज टू हाई, लेट्स सपोज प्रेशर इज टू हाई, ठीक है। सो प्रेशर को कम करने के लिए क्या किया जाएगा, प्रेशर को कम करने के लिए वेंटिंग हम करेंगे। प्रेशर अगर ज्यादा हो गया तो क्या करेंगे, वेंटिंग करेंगे ना, कूलिंग के लिए प्रेशर रिलीज करेंगे, वेंट करेंगे, कुछ स्टीम बनी है कुछ भी वेंट करेंगे उसको, सो दैट इट कम्स टू द कूल, इट कूल्स डाउन एक्चुअली, इट cools down actually. Yes or no? Is it clear to you? Is it clear to you? Let's suppose this signal is PC is gaining higher pressure signal, and PC is, let's suppose, my indirect acting controller. Let's suppose it is giving the decrease signal. Indirect means input high, output low. What is this? AC. AC is my air to close. If air signal increasing, it is going to close. But here it is receiving the low signal, so it will, this valve will release, this valve will increase, this venting valve will increase, opening of this venting valve will increase, and the extra pressure is basically got released here. Is it clear to you? So PC must be the indirect acting, so its gain must be negative. अगर indirect acting है तो gain क्या होगा इसका, negative होगा. Let's suppose it is direct acting, so pressure is already increased here. This controller will receiving the higher signal because it is DC. It is giving the higher signal to this wall. This wall is air to close, so this pressure control will giving the higher pressure to the AC, and this is closed. तो ये तो क्या हो जाएगी, blast वाली condition हो जाएगी. I think this must be a blast condition, right? So this PC must be of the negative gain. Right, so it may be possible that this may be answer or this may be answer. ये आंसर तो नहीं हो सकते. हाँ जी, done. Now come to the CC. Come to the CC. So अगर heavy impurity अगर बढ़ती है, that is the bad situation for us. Bad situation for us. So we should increase the set point of the reflux. Yes or no? We should increase the set point of the reflux. So if CC, let's suppose CC is my indirect acting. Let's suppose the heavy distillate is increasing. Heavy distillate is increasing because it is indirect acting. The output is decreasing. The output is decreasing. That output is decreasing means set point will decreasing. Set point decreasing means that FC will tell AC that okay, do one thing, that close this wall. है ना? Close this wall. Yes or no? This will saying that close this wall. So heavy distillate में क्या करना था अपने को, ओपन करना था. इसको में क्या करना चाहिए था, ओपन करना चाहिए था. yes or no? बट ये क्या करेगा, क्लोज करेगा. That is the unfavorable condition for us. So CC is my direct acting. CC is my direct acting. Increased input, increased output, set point high. AC will go into the going to you can say change the wall position, or means it is increasing the you can say flow rate, and my L will, the flow rate of the L will increase, and that will be my favorable condition. एक बार देखिए प्लीज इसको. So the gain must be positive. हाँ जी बेटा, एफसी को देखो, एफसी के बारे में कोई इंफॉर्मेशन नहीं है तो हम इसको डायरेक्ट एक्टिंग लेंगे, ठीक है. और जो हमने फंडा लगाया पहले वाला, एक बार वो भी आप लगा के देख सकते हैं इसके अंदर, वो भी आप इसके अंदर लगा के देख सकते हैं, जहां पे हमने what we have now the type of वॉल हेयर, तो जो वॉल का टाइप है उसके कॉरस्पॉन्डिंग व्हाट कैन बी द टाइप ऑफ द कंट्रोलर, वो भी आप इसके अंदर फंडा एक बार लगा के देख सकते हैं, ठीक है। इफ अगर कुछ मेरे पास में गिवन नहीं है, then I assume it as a direct acting, that it increase the signal, it is increase the signal, okay. ठीक है, सो दिस इज ऑल अबाउट योर क्वेश्चंस गाइस, ये क्वेश्चंस थे आपके। नाउ होल एंड सोल योर आईपीसी इज कंप्लीटेड फ्रॉम माय साइड, योर आईपीसी इज कंप्लीटेड फ्रॉम माय साइड। ओके, जस्ट रिवाइज इट, नाउ दिस इज द ओनली फंडा, रिवाइज करो बस। एंड कल क्या करेंगे हम, आई विल टेक योर क्लास बिकॉज एट 6:30 मुझे निकलना है, सो आई विल मेक श्योर कि मैं आपकी क्लास 3 o'clock लूँ। एंड आई विल डिस्कस फर्स्ट योर एफएम प्रॉब्लम्स, जो आपके डाउट आए हैं एफएम के, मैं वो डिस्कस करूंगा। उसके बाद जो हमारे पास टाइम बचेगा उसमें मैं इंपॉर्टेंट टॉपिक्स हम रिवाइज करेंगे फॉर द एफएम, ठीक है, बिकॉज आई हैव टू लीव बाय टुमारो एट 6:30, मेरी ट्रेन है तो मुझे कहीं जाना पड़ेगा, ठीक है, डन, ओके है इतना, बोलिए। सो कल आपके जो एफएम के डाउट्स मेरे पास हैं वो हम डिस्कस करेंगे। चलिएगा, सो आई होप गाइस दैट सेशन से कुछ फायदा मिला होगा आपको, है ना, रिवाइज हुई होंगी चीजें, और डाउट्स भी आपके ले लिए हैं मैंने। सो होल एंड सोल आप मुझे अच्छा ही रिजल्ट ला कर देंगे, मैं ये आशा करता हूँ। जस्ट फॉरगेट अबाउट एवरीथिंग, जस्ट अभी ज़्यादा कोई नई चीज़ें नहीं पढ़नी है, कुछ अगर नई चीज़ें आगे भी आ जाए जस्ट इग्नोर इट, जस्ट इग्नोर इट, ठीक है। जो आपने पढ़ा है उसको मल्टीपल टाइम रिवाइज करने का टाइम है, कोई नई चीज देखने का समय नहीं है। सो डू नॉट टच एनी न्यू टॉपिक, एनी न्यू कॉन्सेप्ट, एनी न्यू सब्जेक्ट। रिवाइज रिवाइज रिवाइज, गिव द मॉक रिवाइज, गिव द मॉक रिवाइज एंड रिपीट, दैट्स इट, है ना। गिव अ फुल मॉक लेंथ टेस्ट एंड डू द एनालिसिस ऑफ दैट टेस्ट एंड रिवाइज द टॉपिक्स इन योर नोटबुक एंड दैट्स इट। ये भी यही प्रैक्टिस करनी है आपको, जब आपका 14 का एग्जाम है ना आई थिंक, तब तक आपको यही प्रैक्टिस करनी है, ठीक है। सो आई विल टेक योर डाउट्स ऑफ योर एफएम इन द कमिंग क्लास। कल मैं आपकी क्लास लेके एफएम आपका खत्म कर दूंगा, खत्म इन द सेंस क्वेश्चंस ले लेंगे, बाकी जितना भी मेरे पास समय बचेगा उसमें इंपॉर्टेंट टॉपिक्स में आपको थोड़ा बहुत बता दूंगा, ठीक है। बिकॉज इट्स नॉट टाइम टू रिवाइज ईच एंड एवरीथिंग, वो तो बहुत समय लेगा। अब मेरे पढ़ाने का समय नहीं है, दिस इज नॉट द टाइम जो आपको पढ़ाने का हो। 7th को एग्जाम है, अरे बाप रे, अच्छा ठीक है, तो कल तो हम करेंगे फिर एफएम खत्म करेंगे। अब ये पढ़ने का टाइम है, पढ़ाने का नहीं है, किसी से पढ़ने का नहीं है, खुद से पढ़ने का टाइम है, ये खुद से पढ़ने का नहीं है, ठीक है ना। दूसरों से मत पढ़ो, आप खुद से पढ़ने का, जस्ट रिवाइज इट। कल आपके एफएम के और डाउट्स ले लेता हूं, फिर एक काम करते हैं, तो फिर हम एफएम को कुछ रिवाइज नहीं करेंगे, अगर थोड़ा बहुत समय बचा तो इंपॉर्टेंट टॉपिक्स से एक बार गो थ्रू हो जाएंगे। जैसे आईपीसी मैंने पूरा रिवाइज करवा दिया, ऐसा नहीं करेंगे, बहुत टाइम टेकिंग प्रोसेस है। डाउट्स लूंगा आपके जो भी मेरे पास आए हुए हैं, और बचे हुए टाइम में थोड़ा बहुत मैं डिस्कस कर लूंगा, दैट्स इट। चलिए, थैंक यू सो मच, बाय बाय एंड टेक केयर। अब जाओ अपना खाओ पियो मस्त, जाओ, चलिए, गुड नाइट।